Hi. Is microphone working? Yeah. Okay. Thank you for the invitation, and thank you for organizing this, and thank you for coming. Coming after work is never easy. Everyone wants to go back home, have dinner, and sleep. So thank you again for coming. It has been a tiring day for me and for my team as well, but I will try to ensure that Zilliqa, yeah, try to ensure that Zilliqa is something cool and that you appreciate what we're doing. So I'll give a brief introduction for myself, and essentially I'm a researcher by profession. So I did a PhD in France at INRIA, and essentially I was working on privacy aspects of software systems. So what happens when you use a software coming from a third party, what kind of private information it actually collects from you, and what it can actually do with it. Then I moved over to Singapore to do a postdoc. So postdoctoral research is something that you do after your PhD to kind of gain more experience in research. And there I got an opportunity to work on blockchains, especially the privacy aspects of it. So I tried to understand how blockchain or what kind of privacy features blockchains provide and how private they are in practice. Like what happens when you actually use a system like Bitcoin or Monero or Zcash, what kind of privacy you actually get from it? And what kind of attacks can an attacker actually kind of mount with the data that's actually in public in the form of blockchain. And during my postdoctoral research, I happened to get invited to work on Zilliqa, which essentially will be the topic of discussion today. So what are we doing at Zilliqa? So Zilliqa is essentially a blockchain platform which is scalable. Now, what do you mean? What do we mean by scalable? Is essentially this. So if you look at what other blockchains are doing, especially the most popular ones, for instance, Bitcoin and Ethereum, they process around 10 transactions per second on average. Sometimes much less than that. And this is a big limitation because if you ever decide to build a real world application such as payments, for instance, and try to see what kind of payment infrastructure is it okay? Yeah, okay, yeah. What kind of payment infrastructures, what kind of transaction throughput actually a payment infrastructure requires, for instance, Visa. So Visa, when you actually use in practice, they require around 5,000, they actually process around 5,000 to 8,000 transactions per second, while Bitcoin processes around 10 transactions per second. So there's a huge gap between what blockchains, popular blockchains like Bitcoin and Ethereum process, and what's required from a real world application. And this is where kind of people try to solve this problem. And they realize that if you really ever want to build a real-world application, you have to solve this scalability problem. So you have to increase the throughput from 10 to something much larger. And there are some obvious solutions to it. One is, why don't you increase the block size? So if you're familiar with how Bitcoin works, essentially, Bitcoin is a blockchain, and a blockchain is a chain of blocks. Now, a block can only fit a certain number of transactions because a block has a fixed size. In the case of Bitcoin, it's 1 megabyte. So the point is that if you actually increase the block size from, let's say, 1 megabyte to 2 megabyte, you can actually insert much more transactions into it, and hence you will get a higher throughput. Well, you can certainly do that, and it will certainly give you an immediate throughput result. But you can only increase from, let's say, your block size from, let's say, 1 megabyte to 2 megabyte, probably 10 megabyte, but you cannot make it to 1 gigabyte, because the moment you go to a certain bound, you have to take this block and transport to the network. And when you do that, you end up with bandwidth issues. Imagine using your Gmail with a 1 terabyte of file. Gmail starts complaining. And the reason is network. The same problem will happen if you increase your block size in Bitcoin. Oops, sorry. So this is what happens when you start increasing your block size. You end up with bottlenecks. So it's an immediate solution, but it's not the full it's not a complete solution, and it's not the ideal solution that you actually expect. There are other solutions such as off-chain solutions. If you're familiar with Raiden, Lightning Network or Trinity, which is an off-chain solution for Neo, these solutions can actually give you very high throughput because what happens is you don't push every single transaction on the main chain. So you don't push every single transaction on, let's say, Bitcoin or Ethereum. You do a bunch of transactions off-chain, and then now and then, let's say every month or every week, you push a transaction on-chain. Now, because you're kind of removing a lot of transactions from chain, you will actually get high throughput because the network does not have to process those many transactions. But there are downsides as well. You can only do certain kind of transactions, for instance, payments, but you cannot run smart contracts. When you start doing it, things become slightly more complicated. There are other aspects, for instance, there are issues like decentralization, security issues that come in play as well. But still, this is something that's needed. Off-chain solutions are required for certain applications. For instance, let's say you want to count the number of likes that you get on a Facebook post. You don't require that much of security, and you could probably push it off-chain. And so, they are kind of complementary solutions to on-chain scaling, on-chain scaling. But yeah, they have their own limitations. And this is where Zilliqa comes in. So Zilliqa is an on-chain solution. So we don't go off-chain, we don't go side-chain, we are completely on-chain. And the property that we're looking for, the property that kind of Zilliqa offers, or the feature that it offers, is this linear scalability. I don't know if I can point something out. Oh, yeah, OK. So if you look at here, we have, when we have 1,800 nodes, we have a throughput of around 1,200 transactions per second. So these are the numbers that we actually obtain from experiments. So these are not hypothetical numbers. So we have our platform almost ready. That will be live very soon. And these are the numbers that's coming from that platform. So if you have 1,800 nodes, you get a throughput of around 1,200 transactions per second. Now when you double your network size from 1,800 to, let's say, 3,600, your throughput doubles as well. Now, this is a property that's not available in any blockchain platform, to my knowledge. And this is what we call linear scalability. So more nodes join your network, your throughput goes up as well. If you look at how Bitcoin and Ethereum works, every single transaction is processed by every single node. So the more nodes you have, the throughput will actually go down. And this is completely opposite of what we are doing in Zilliqa. So the more nodes you have, the throughput goes up. We are a Singapore-based company. We flew from Singapore for a Euro trip, and so we have a bunch of researchers. So most of our team, I would say 4 people, have, or probably more even, have a PhD degree. So we are a bunch of academics, with some people who come from financial backgrounds, who have already set up companies in Singapore and in London. And there are other people who are veterans in different fields. And we decided that once we have this academic idea, we should try to actually build a product out of it. And hence we built Zilliqa. But before that, how Zilliqa got started was this idea of sharding. And I don't know if you're familiar with how databases work. So there's an idea of sharding in the field of databases, where what you do is you take your database, which is essentially a bunch of rows and columns, so a matrix, if you want to say. And then you take a bunch of rows and you say that my first server is going to only handle my first set of rows. The second server is going to handle the second set of rows, and so on and so forth. So you're kind of dividing your entire database into a bunch of smaller number of rows. And this is what is called sharding. So you divide your data into chunks called shards. Now this is an idea which was pretty known in the field of databases, but intuitively, this is what you want to do as well in the blockchain space to gain throughput. And it was in 2015 that some of the team members published an academic paper to show that how would you implement, or how would you actually use this idea of sharding that comes from database, and how would you apply it in the context of blockchain. And once we had this paper, we thought we should implement it in a real-world kind of setting. And we did exactly that. So what we did was we took this idea and we implemented it, but in a permission setting. So in a permission setting, you kind of authorize nodes to join your network. It's not open to anyone, unlike Bitcoin and Ethereum. So we implemented this in a permission setting, and then we trialed with a bunch of banks and exchanges that we had in Singapore. And we saw that, this sharding actually works in practice. So you actually get high throughput when you increase the number of nodes. But then we ended with this problem that you don't have enough nodes, because in a permission setting, you have a bunch of banks, a bunch of exchanges, which want to do some kind of settlement among themselves. So the number of nodes that you can expect is around 10 to 50, not more than that. Now, when you have only these many enough nodes, you cannot actually get high throughput. It's still pretty limited. And the only way to actually show the real strength of Zilliqa, or the real strength of sharding, is to make it public. So what we did was we took this kind of permission kind of setting, and we kind of redesigned it a little bit, and then we got Zilliqa. So Zilliqa is an open blockchain platform, just like Bitcoin and Ethereum, where the goal was to increase the throughput by over 200 times. So as I showed a little earlier, that our throughput was around 2,400 transactions per second with a network of around 3,600 nodes. And so the main goal was to scale, so to get a high throughput. And there are a bunch of things that we did as well. So the one thing is, the one immediate effect or impact of high scalability is on transaction fees. So if you have ever transacted on Bitcoin, sometimes under network congestion, a $10 transaction can actually cost you $2. So you can pay $2 just for a $10 transaction. And if you have a high scalable platform, then the transaction fee will actually go low because you don't have to compete with everyone else to actually get into the next block. This is what happens in Bitcoin right now because they can only process 10 transactions per second, so everyone is fighting for that 10 transactions. And the only way you can actually get in is by putting a high fee. So if you have a scalable blockchain platform, then it has an immediate effect that your transaction fees will go down. And we also did a bunch of things about smart contracts. I'm going to talk about that a little later. So Zilliqa is not Bitcoin. It's more like Ethereum in the sense that you can actually deploy dApps. So you can actually run smart contracts on top of it. So one of the examples that we are working on is the case of digital advertising. So if you're familiar with how digital advertising works, you have a bunch of advertisers who want to advertise their product. And then you have a bunch of publishers, for instance, let's say Wall Street Journal, BBC.com, or whatever. And these advertisers can actually advertise ads on those publishers. And publishers could say, you know what, I have this much of space. I can post 1 or 2 or 5 ads. And depending on the voting or bidding process, you get to place your ad on a publisher's website. The problem with existing method of digital advertising is that there are a lot of middlemen. So it's not just about publishers and advertisers. It's about a lot of people actually in between these two entities. And all these entities, they are not just for free because there's no free lunch. People actually take a cut out of the system. So advertisers lose a lot of money because they have to pay, a hefty sum. And they don't actually know whether the ad campaign that they are actually paying for is actually bringing any value to it. On this app publisher side, because of this middleman, they don't get money. So if they suppose if a publisher deserves to get $10, they actually get $2 because all these middlemen take a cut out of it. And there are other problems, for instance, ad fraud. Sometimes you get weird ads that has nothing to do with what you're interested in, or that has nothing to do with the publishers themselves. And it sometimes it gives a bad reputation to publishers. So, a BBC.com, webpage certainly does not want to publish weird ads that has nothing to do with a meaningful in a meaningful context. So there are a bunch of problems with advertisings, and one solution is that you could probably put it back on blockchain, where you could ensure that there are no middlemen. So you could have a bunch of contracts. You could have one contract for advertisers, and one contract for publishers, and you could have a way to correlate ad spaces with ads, and then you could actually eliminate a bunch of middlemen directly. And it also ensures that because you have smart contracts, you could actually audit a bunch of things, so you know that what's happening. It's more transparent, unlike what's happening with, let's say, big giants like Google and Facebook, where you have a lot of middlemen and no one knows what's happening. Now the question is, what happens when you take this example, when you take this dApp and you implement on existing platforms like Ethereum? So Ethereum processes around 10 transactions per second, which is roughly, if I'm not wrong, is around 1 million transactions per day. But if you look at these ad kind of applications, they can produce billions of ads per day. Now, even if Ethereum decides, or Vitalik himself decides that my Ethereum network is only going to process ad-related transactions, even then, the network can't actually support what ad campaigns actually require. So, none of the existing platforms are actually capable of handling that much of traffic. And also, there are issues like with smart contracts. I'm going to come to it a little later. And we feel that Zilliqa, with its high throughput, can actually become a game changer in this system. So we are closely working with a media agency called Mindshares. So Mindshares is a big company which kind of work with both publishers and advertisers. And we work with them to understand the exact problems that they're facing and to be in the space to understand what kind of requirements they have and how to solve them. So this is one partnership that we already have, and we're working very closely with them on building a dApp with them. There are other dApps that you can imagine. For instance, let's say shared economy. Can you do Airbnb on blockchain? Can you do Uber on blockchain? And why are we targeting these? Because they have really high throughput requirement. Look at Uber, for instance. They certainly cannot survive with 10 transactions per second. They need much more. And there are other kind of applications that you can imagine where you have one basic application is this payment network. So you just want to do payments. And even in that case, if you want to get close to Visa, you need a pretty high throughput, and low number of transactions per second won't help you much. So now I'm going to give a very quick overview of what we do and how Zilliqa works, so that you could appreciate that the fact that there's some clever idea that we're employing in Zilliqa, and that's not there in any existing blockchain. And the idea is sharding. So the high-level idea is that so if you look at how Bitcoin and Ethereum work, every single node in the network, at least every single full node in the network, has to process every single transaction. So imagine I, as a user, creates a transaction, let's say in Bitcoin. I create a payment kind of transaction where I'm paying to some other user. That transaction goes to the network, and then every single full node in the network has to process that transaction. Now, if you have a Bitcoin or Ethereum-like network where you have around, let's say, 20,000 or 30,000 nodes, well, you certainly do get good security because everyone is processing the transaction. So it's very decentralized. But then you also are doing a lot of redundant computation. So everyone, you don't want 1 million nodes in your network to do the same computation because we are wasting a lot of the computational power. Now the question is, can we do better than that? And the answer is yes. And how would you do that is this by employing this idea of sharding. So what you do is you take your network. Let's say you have a network of 10K nodes, 10,000 nodes. You divide that network into smaller groups, let's say 1K nodes. So you can have 10 groups of 1K nodes, 1,000 nodes. And then you want to ensure that each subgroup, so each 1K node can process transactions in parallel. So if you don't have conflicting transactions, then each node can process transactions in parallel, and then hence you can have high throughput. Now the idea is that if you have more of these 1K nodes, more of these subgroups, you can have more throughput. And this is how linear scalability comes in. So the more nodes join your network, the better throughput you will get. Well, at a high level, this is the simple idea. But to make it work, you have to do a many stuff, and because it's pretty challenging. For instance, how would you create those shards? How would you create those smaller networks? How do you ensure that a malicious node does not bring in all nodes in a specific shard and kind of takes control of it? How do you ensure that transactions get divided into or get assigned to different shards in a way that there's no conflicting transactions? So you can actually process in parallel in effect. And there are a bunch of other problems. For instance, how do you reach consensus? How do you ensure that nodes in a shard agree on a set of transactions or agree on producing the next block? And how do they do that? So there are a bunch of things that we have done. For instance, there's a standard protocol in literature called PBFT, so Practical Byzantine Fault Tolerance. This is a protocol which is different from the protocol being used in Bitcoin or Ethereum, which is proof of work. Sorry. And this consensus protocol is not computationally intensive as proof of work, because if you know how proof of work works, is that everyone is kind of fighting to become the next block proposer. So everyone does proof of work, and the one who comes with the fastest, who kind of becomes the fastest, gets to propose the next block, and everybody kind of accepts or rejects it. So there's one winner, and everyone kind of fights to become that one winner. In PBFT, you kind of together work by voting mechanism. So everyone kind of votes to say, OK, I like this block. I'm going to propose this block. Similarly, someone else would say, I like this block, and I would propose this block, and probably a few of them might say, I don't like this block, I'm going to reject it. But depending on how these voting numbers are, you actually propose the next block. So there's not much of computation involved. What is involved is more communication. So you talk to other people rather than doing a lot of work. So it's going to be very, very energy efficient. So you don't have to take your mining rig and keep mining the entire life. There are other as I said, you have other advantages. For instance, because of the scalability, you always get low transaction fees. And there are other mechanisms. For instance, in Bitcoin, there's one winner, and that winner gets all the rewards. So let's say 6.25 Bitcoins or 12.25, 12 Bitcoins. In this kind of PBFT mechanism where everyone is kind of voting, you can actually say, I'm going to reward everyone, because everyone is kind of participating in this the generation of the next block. And because of that, you could ensure that everyone kind of gets reward. And with this, you ensure that there's a stable reward mechanism, that there's not one guy who becomes richer and richer. And so variance of the reward that you get will go low. So it's going to be more stable and uniform. We are also working on the smart contracts aspect of it, because I said earlier that we are more like Ethereum in the sense that we have smart contracts on our platform. We will have smart contracts on our platform. And why did we decide to develop a new smart contract, or why did we decide to innovate on smart contract? And the reason is essentially this. So if you look at the most popular blockchain platform which supports smart contracts, which is Ethereum, they had a bunch of issues in the past, especially with it started with DAO, where some attacker was able to find a bug in a contract and was able to drain funds out of it. So he could steal around $60 million from that contract. A few months ago, an incident called Parity happened. So Parity was a multi-sig wallet, and an attacker intentionally or unintentionally killed the contract. And because of that, around $300 million got frozen. So you could see that there's money there, but no one can actually retrieve it. So it's stuck there. And there are many people who probably one of you may have their own money there. And the problem is that, okay, you know that there have been incidents in the past. You know that some contracts have bugs. But it's not going to stop, right? Because you never know when the next contract is going to come and it will have bugs, and so that attackers can actually go and exploit it. So the question is when that next contract will be discovered, which will have bugs. Let me get a slightly at a higher level. Let me explain you why those contracts have bugs in general. The main point is complexity. So if you know about smart contracts, it's a pretty complicated thing. The reason is a smart contract is, first of all, it's like any other program that you write in C++, Java, or whatever language you prefer. So it does a bunch of computations. So it could do mathematical operations like addition, multiplication, anything that you can think of. It also has a state. So let's say you can have a state where you could say, okay, who contributed how much amount in this IC or whatever. So you can have a state, that mapping. And that mapping is being manipulated by every miner at the same time. So users are actually sending transactions, and then miners kind of serialize them in a way and then update that state. So there's a global state. There's a bunch of local computation that's happening. And the worst part is that a contract can actually talk to other contract. And that contract can again talk to another contract, and so on and so forth. So it can go to infinity. I mean, depending on the gas fees, but yes, in theory, yes. Now, what happens if a contract, which is essentially a program, does all of this? The problem is not just about what it does, but it's about where it does it. Where all of this happens. It happens in a Byzantine environment. It happens in a malicious environment, where a user like me who is sending transaction can be malicious. So I might try to steal funds, or might try to be clever and do what the Parity guy did, who kind of killed the contract. Or I could have miners who are malicious, who could be trying to do some nasty stuff. Or even worse, a contract can itself be malicious. So you can imagine a contract talking to another contract, and that contract itself is malicious. Now, Imagine all of this happening together. So complexity together with the environment where all of this is working. So smart contract is run. And what happens with this is that a developer like you or me, when we write a contract, we could say that, you know what, my contract is going to do certain things, like this, this, or this. You could check that. But it's hard for you or hard for us to say, my contract is not going to do this. It's not going to behave like this. Because you don't know. It's such an unpredictable environment that you don't know, what factors will come into play and can try to generate unexpected behavior. So there's a kind of a gap between what you expect your contract to do and what your contract can actually do in practice when you deploy it on the network. And because of all of this combined, it's hard for any developer to kind of give mathematical proofs about your contract. So if you're familiar with formal verification, what happens is when you write mission critical programs like for NASA or your, let's say, I don't know, Airbus, or Boeing or whatever, you need to give very strong properties about the contract or the program that you write. You need to say that, okay, my contract or my program is not going to behave maliciously or is not going to show certain bad behaviors. With smart contracts running in this malicious environment, it becomes very, very difficult, believe me. It becomes very, very difficult to prove mathematically that contracts are actually safe. Now, this is where we try to innovate. So we are working on a new language called Scilla, which is a simplified version, if I may say so. It's a simplified version of Solidity, where we try to structure the language. We try to structure how a developer should write a smart contract in a safe way. I'm not going to go into the details of it, but essentially, it's a simpler language where it's easier to detect bugs, and it's easier to prevent certain kind of bugs, and it's easier to prove mathematically that your contract is going to be safe. We are working on a bunch of different problems right now, both research and engineering aspects of it. So for instance, we don't want, this is a new language called Scilla, but we don't want developers to learn a new language because no one wants to learn a new language. Imagine you learning a French or, I don't know, German or whatever. It becomes very difficult for a person to learn a new language every time somebody decides to create a new one. So what we are trying to do is we are trying to minimize this learning curve as much as we can. So we believe that Scilla is going to be an intermediate level language. So developers are not going to write directly in Scilla, but they're going to write in a higher level language, which is going to be very close to Solidity, if not a subset of it, so that you don't have to learn a new language. And then we'll have compilers that are going to take your contract and compile to written in this high level language, and will compile it to Scilla. We are also working currently on how to run those contracts on a sharded architecture like Zilliqa, where you have a bunch of shards, and shards can try to manipulate the same state variable at the same time. Where are we now? Essentially, we had this test in December where we reported a transaction throughput of 2,500 transactions per second with a network of 3,600 nodes, so which is roughly more than 200 times what Ethereum can process without sacrificing security and decentralization. We are soon going to be releasing a testnet where we want people to come and help test the protocol that we have right now, which is essentially a sharded, which essentially implements this idea of sharding. And we would be happy if you could attack us right now and help us fix bugs if you have any. And in the kind of a longer roadmap, we are targeting a mainnet in Q3 where you could actually come and write dApps and actually run on Zilliqa. Well, that's it. Thank you for your patience, and I'm happy to take questions. Yeah, please.
Do you have an idea of the level of parallelism that will be possible with only 6 shards? Does that mean that I have only 6 concurrent tables that I could append data to? Or?
OK, so let me tell you that they're just one table. There's just one table. So what you're referring to is something called state sharding, where you take a table, you're mapping, and you divide them into different shards. We are not doing it. What we're doing is every single node in every single shard maintains the same ledger, the entire copy of it. What is distributed is the computation. So not every member of every shard has to validate every single transaction. I will give an example, for instance. Let's say you have 2 shards, and we have 2 users, Alice and Bob. So every transaction coming out of Alice will go to the first shard, and every transaction coming out of Bob will go to the second shard. Now, if you do this, you could actually prevent double spends directly at the shard level. So if Alice creates 2 double spend transactions, both of them will go to the same shard, and then the shard will actually be able to detect that transaction.
Yeah, so both Alice and Bob are able to create all types of computational transactions. For example, they could create 10 types of computational transactions that will be divided over 2 shards.
I don't understand. Yeah.
In a smart contract environment, it's not just a monetary
Exactly. So we are currently. This is what my plan was. We are currently working on this what we call sharding-friendly smart contract. So what we're trying to do is, you want to ensure that conflicting transactions. So if you have, 10 computational or whatever you call it, this smart contract-related transactions, they get handled in a single shard, so that you don't have problems with that. So we'll soon be releasing a paper on this. We'll show how to make it work. Yes.
So Zilliqa still on track to deliver the testnet 1.0 this week?
Yes, we are on track. Yeah.
So it will be.
Yeah, it will be. Yeah. So I mean, in the current version, we have this consensus layer built in. We don't have rewards. So when you mine this testnet, you won't get rewards. We don't have incentive layer. So when you send a transaction, you don't have to pay for transaction fees. So in this kind of setting, you can actually spam the network. So I could create 1 million transaction, and I could send it because it costs nothing. So you'll have some kind of a spam prevention mechanism, essentially whitelisting kind of mechanism to prevent, to ensure that we don't get spammed. But yeah, it's on track. Yeah.
Is there an overhead in data involved in doing sharding? Will each node will it require a lot of data to do this? Because I guess they need to be synced.
Yeah. So I mean, it's a general problem, not specific to sharding. Imagine a network that processes, 10K transactions per second. Now, there are 2 ways of doing it. One is that everyone stores the entire thing, okay, which is a possibility. The other idea is that, only a subset of the nodes. So let's say one shard could only store their transactions. For instance, my example with 2 shards, and transactions coming from Alice go to one shard, and transactions coming from Bob go to the second shard. In this kind of setting, this first shard could only maintain the balance of Alice and not maintain the balance of Bob. And this shard could only maintain the balance of Bob and not for Alice. You could do that, but then the problem is that what happens when a transaction goes from Alice to Bob, then you will have to do cross-shard communication and all that stuff. Now the question is it worth doing? The answer is, I don't know. Because it's super complicated, to be honest. And it's hard to know, at least I don't know, whether it's worth doing it. Because let's imagine this Bob is a very popular person, I don't know. He's accepting donations from everyone. Now, every time there's a transaction going on, you will have to talk to every other shard. And this will probably lead to a lot of communication overhead. And probably, it's better just to store the entire state everywhere. So yeah, in general, this is a problem with any scalable platform, is that you have a lot of transactions, so somebody has to store it. And it's not specific to sharding.
Because that's bad for decentralization, right? Because you have a lot of data requirements, not everyone is able to do it.
Yeah.
So not everybody can participate.
So I mean, there are a bunch of solutions that you could imagine. One is that you could prune the data. For instance, I mean, we are not working in a UTXO model like Bitcoin, where if Nakamoto mined the first block, you still have to store that first block, because you never know when Nakamoto decides to spend that block, because decides to spend that UTXO, because you're working in a UTXO-based model. We are working in an account-based model where, like Ethereum, where you could say, I don't have to store every block, which I don't know. If I decide to create a block today, probably I don't need it after 5 years because I've already spent it. So you can do some kind of pruning to prevent, to kind of get rid of blocks that date back to prehistoric times, and stay with more recent blocks. So there are a bunch of strategies that you can do with it. Yeah.
It seems that there are many micro blockchains under Zilliqa, so many small blockchains work together.
Mhm.
And you didn't explain, or I didn't understand, how the governance will work, and who will decide the nodes, which nodes will be in this group, or how this group will communicate with other groups.
So it's not that you did not understand, it's that I did not explain. And the reason is the following. So what happens is that, okay, this is not the right picture, but anyway. The point is, so let's say at a certain point of time, you have a bunch of nodes, let's say 1,000 nodes that come in, and you want to ensure that these nodes go into some specific shard, right? And how we do it is using proof of work. So we ask the nodes to do proof of work, but it's not a proof of work as in Bitcoin where you do proof of work for every single block. You do it once in a while, let's say every 2 hours, every 5 hours. You can decide the frequency. And when you do a proof of work, you give me the result that you obtained. And because in proof of work you have randomness, what I could do is I could leverage on that randomness and say if your proof of work ends with a 0, you will go to the first shard. If your proof of work ends with a 1, you go to the second shard. So I can ensure that the randomness helps me to assign nodes to specific shards.
Who you are.
Okay, me is a specific shard.
So it means that nodes also can decide about.
Nodes are the only one who will decide. So what happens is that you will have 2 specific shards that, let's say, in your setting, and there's something called directory service committee. So it's a special shard that is responsible for assigning nodes to shards. So this is me.
So they also have their own share from the award.
Yeah, they also get rewards. Yeah, they also get rewards. Yes, please.
What is the minimum number of nodes that should be in any shard?
Exactly. Okay, so now this is a very crucial question because let's say I have a shard with just one single node. I can very well do that. But then your shard becomes pretty centralized. So whenever you send a transaction, this guy is going to reject it. If it's malicious, it might reject it. You increase it from 1 to, let's say, 2, you get slightly better chances to get accepted. Now the question is, what's the best number? And we went with a number which is 600. So in each shard, we have 600 nodes. And the reason why we went with 600 is that, so we have an assumption on the initial network, which is that 1/3 of the initial network, let's say of the 2 10K nodes that I initially had, only 1/3 of them can be malicious. And what I could do is, if I use this proof of work mechanism to sample nodes from that network to build a shard, I can ensure that if I have 600 nodes in this smaller group, then the probability that this smaller group of nodes will also have only 1/3 of malicious nodes is going to be very, very high. So yeah, this number is very, very important. And 600 gives you a high probability that this shard will not be entirely filled up with malicious entities.
So the randomness basically secures that you cannot attack only one pool of nodes.
Yeah, yeah.
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 So it would be a higher percentage.
Exactly. I mean, this is the general idea that works in security. If you want to beat an adversary, use randomness. And in most of the cases, as far as I have studied in security and privacy, the best way to beat an adversary is randomness. Because randomness is something that an adversary cannot guess, unless your randomness is biased or whatever.
And then you're sharding the pool of the distributing nodes? How do you
That's again 600 nodes. And it's again selected using proof of work.
And they cannot be attacked? That's selected.
What do you mean attacked?
Well, malicious...
Well, you can have a malicious node in that network. But the point is that as long as 1/3 of them are malicious, you are OK.
How do you choose which goes into the shard that is on top of randomness, putting the different results in the different shards?
So you look at so I ask you to do proof of work. You come back with the result. And because of proof of work, which has randomness involved in it, I would look at the result that you gave me and will check. So proof of work has a bunch of zeros at the beginning and then a bunch of numbers at the end. I will look at the last bit. And if it's 0, I'm going to assign you to the first shard. If it's 1, I'm going to assign you to the second.
Become a
No, there's no center. There's this DS committee that does, so directory service committee does it. Yeah. But this has, again, 600 nodes. So every DS is just another shard, just a specific shard that we call DS. And it is, again, responsible for assigning. Yes?
So how are you guys going to stimulate the adoption of your platform? And also maybe a bit more in detail, because a lot of projects are now based in Ethereum, and you're saying your language is kind of comparable. So are you targeting those apps that they can switch easily from Ethereum to Zilliqa, or like you said for Uber and Airbnb, are you targeting centralized bigger corporations to switch to blockchain? How are you doing so?
So there are two aspects where through which we are trying to attract people to our platform. One is by trying to be compatible with Ethereum as much as we can. For instance, when we use proof of work to join the network, we are using Ethash, which is the proof of work mechanism used in Ethereum. So if you are an Ethereum miner, you could actually take your hardware and use it to mine on Zilliqa. The other point that we have is dual mining. So when we do proof of work, it happens every couple of hours. So let's say you do a proof of work now, and then for the next 2 or 3 hours, you don't do proof of work. And then again, after 2 or 3 hours, you start doing proof of work. Now, during the period when you don't do proof of work, you could actually go and mine Ethereum. So you mine Zilliqa, and then you do whatever Zilliqa asks you to do, which is not computationally intensive. And in this period, you can actually go and mine Ethereum. So we are trying to be compatible with Ethereum as much as we can. One aspect on mining. The other aspect is on the language side. So we do realize that we have a new language, and we are trying to make it Solidity-like so that we can attract developers there. We have to understand, and everybody has to understand that Ethereum has issues. We all like Ethereum because of what they have done, and Bitcoin, of course. But Ethereum has issues, especially on the scalability side. And if you as a developer wants to build an app, if you want to build an app, and you say that, my dApp requirement is only 2 transactions per second, then still you have to move out of Ethereum. Why? Because even if you are within the Ethereum limit of 10 transactions per second, and if your requirement is much inferior, but you should not forget the fact that you may have someone playing CryptoKitties. Now, if you have a dApp like CryptoKitties, which requires, 1,000 transactions per second or whatever, then you won't be able to run your dApp because they are going to consume the entire bandwidth. So we are targeting both dApp developers who are actually running on Ethereum. Either they switch or they build a similar dApp on our platform. Or we are also, at the same time, we're also targeting new applications, for instance, Uber. Why blockchains have not been, have not got that much of adoption in the real world is because of one reason is throughput. Imagine building a dApp, and the first thing that you require is throughput. The moment your dApp becomes popular, and the moment you have 1,000 users, your dApp just won't work on Ethereum.
So what makes you confident? Because Ethereum is also investing in their scalability issues, right? And they have a lot more developers at the moment than you do, probably. I saw you guys also had a meeting with Vitalik, right?
Sorry?
You had a meeting.
Yeah, we had a meeting with Vitalik.
So what makes you so confident that you guys, I know you're doing a different kind of sharding, but what makes you so confident that you guys are going to implement it on a really short notice, and that maybe Ethereum is not going to beat you to it, or you can live together? I mean, what makes you so confident?
Okay, we do want to live together. We do want to live together. But let's try to understand what Ethereum is doing. You said that we are doing different kind of sharding. So they are whatever. Let's say we are doing the same kind of sharding for the time being. But the problem with Ethereum is that they have an infrastructure which is already there. Now it's not just about tweaking it; it's about rebuilding it from. You have to rebuild a bunch of components, and it's not that easy, to be honest. I mean, even with Scratch, when we are doing it, there are a lot of complications. Believe me, there are a lot of things that you have to take care of. And when you already have an infrastructure already there, it becomes much more difficult. I'm not saying that they cannot do it, but it's way more difficult than doing from scratch. So in that respect, we have some advantage. But I agree that we don't have as big community as Ethereum has, developer community. We don't have 1,000 people working in different parts of the world and working tirelessly and selflessly for Ethereum. hopefully, one day we'll be close to that, or at least, we'll have enough developers willing to work with us. So one aspect that I personally feel is lack of, complications with our approach. Because we're building from scratch, we have a lot of liberty in doing what we want. For Ethereum, it becomes much more complicated, especially with legacy applications. So imagine you have an application that's running already. How would you ensure that that application continues to run in the way it has been running until now? So they have challenges. I cannot reveal what we talked about, but there are challenges that they're facing, and we'll be happy to learn from them, and I'm very sure that they will be happy to learn from us. Yeah.
Based on your answer that you gave on because you start from scratch, what is the maximum transaction that you can provide, or that you propose to provide based on the speed? You say in order to reach the Visa, the comparison same number of transaction 8,000 per second. For Visa, you have to have 10,000 nodes.
Yeah, roughly, yeah, probably more. Yeah.
So what is the maximum number of nodes, or what is the maximum speed that you can reach?
Sure. There are a few parameters here. One is the number of nodes per shard, and the number of shards that you can have, okay, and the throughput that you will get. So it will. I mean, this is our hypothesis, and I'm very sure that this hypothesis is going to be correct, because I feel it's very scientific. The reason is we feel that it's going to scale linearly until a certain point of time, and then it's going to go plateau. And why is it the case? Because when you have more shards, you will get, your throughput will linearly increase. But at a certain point of time, when you have, let's say, I don't know, 1,000 shards, or or probably 100 shards or 200 shards, you will have to communicate a lot of data to other shards. And because of that, you will start getting a plateau kind of output. And I don't have a precise number on how much we can get. I personally hope that we'll hit around 10K or probably more. But for that, we are kind of releasing testnet to actually see what kind of output we'll get. So in theory, I don't know, but
So you think it's 10K?
it should be around 10K. I mean, I can't guarantee that we are going to touch 1 million transactions per second, because I feel that's not realistic. I mean, in a secure platform, I don't think yeah, please.
Yeah, one question. Like those 36 nodes that you're talking about, were they all running in one region in AWS, or were you using all regions?
So currently, I agree that there's a limitation here. So all our nodes are running in Singapore, and we could have done better. We could have distributed our nodes in different countries. But for some reason, we had to do it in Singapore, and we exhausted the entire quota in Singapore. So we couldn't go beyond 3,600 nodes, and we had to stop it there. But yeah, hopefully by our testnet, we can expand and distribute it to different.
Because that's one of the limiting factors for Ethereum as well.
I agree. I will be happy to get results from network when we open it. Yeah.
Will there be a mechanism for auto price discovery of the fee market to keep incentivizing nodes to scale dependent on demand, on computing demand? Because if at night half the world is not on the internet, not requesting advertisements, then the load of the network will go down, and therefore will impact the fees. So is there a price discovery mechanism to make sure that there's an optimal amount of nodes in the shards for the load that is requested?
That's a very interesting question. I don't have an answer to it. Probably someone will figure out a way to do that. But that's a very interesting question. But just a second. I mean, by the way, miners generally decide the price depending on the congestion. So I mean, if there's not much of load, probably they'll figure out a way to. We cannot impose an incentive mechanism on the nodes.
Yeah, so they decide for themselves based on.
It's going to behave like Ethereum.
They don't vote like in Ethereum on the fee structure.
You can decide a mechanism to vote, but essentially when you are agreeing, you are actually voting. When you say that when I propose this block, I'm not going to accept this block if it doesn't have enough gas fees. So it's more or less kind of voting, kind of indirect voting, not direct. Yes.
The TPPF protocol that you're having, isn't that, well, kind of the same with the one for Hasgraph is implementing, and how does that compare when you compare the blockchain architecture with the dApp?
So no, we are. It's not the same. So hash graph is a very different mechanism where, if I understand the idea correctly, it's essentially you learn something. So when you see a block, you say, I have seen this block, and then you kind of pass this message to other nodes saying that I have seen this block and I've seen this because someone else sent it to me. So it's more about gossip about gossip. So when you receive something, you gossip about it and you kind of gossip the entire history. And there's some kind of a virtual voting mechanism that runs behind the scenes, which is very close to BFT, Byzantine fault tolerance. So yeah, BFT and PBFT are close, but Hashgraph and PBFT are kind of different. And your general question is how well it will do or how different it will be. We'll see. Currently, Hashgraph is running in a permission kind of setting, so we don't know how well it will do in a more public network.
How do the different shards come to consensus then? Sorry, maybe I missed it.
How different shards will?
The different nodes come to consensus in the different shards. How is it a different mechanism? The shards in between themselves come to.
So currently there's no consensus. There's no consensus across shards because you don't need it. If you are processing only transactions within a shard, you could say, I have processed this shard, you accept it or reject it. If you reject it, if the other shard rejected, then your shard is kind of behaving maliciously entirely. Because the assumption is that nodes, only 1/3 of the nodes can be malicious. You hope that the rest of the network, which is 2/3 majority, will accept the state that one shard is proposing. So there's no cross shard consensus. Yeah.
So you were saying that you expect around 10,000 transactions per second, right? Roughly.
Yeah.
Can I take that number? Because you're also showing that Visa has around 2,500, right? So do I understand it correctly if that is at some point in time Zilliqa can have 10,000 transactions per second, that you can have 4 Visas on your network and then it stops? Or
Well, it cannot go infinitely.
Because you also said that it was clear that it works best when you have a public blockchain, right?
Mm-hmm.
So does it mean that you can serve Visa and 3 other Visa-like, or like Uber and Airbnb, and then another high-volume transaction business, and then it's done? Or how do you see an option to have? I mean, if it really becomes like a game changer, then how can you assure that more companies with a high throughput of transactions can make use of it?
So yeah, I mean, this is a very good question. There are limitations on throughput. You cannot have 1,000 or 500 high throughput applications running at the same time. It's not going to work well. So yeah, I mean, you need some kind of anchor applications that show that, okay, this is a real world use case. For instance, digital advertising. You pick any example, right? And the first point is that you show that a real world example that actually requires high throughput can actually work in practice, number one. And then you can have all those subsidiary applications, like payments or even simpler ones like CryptoKitties, which do not require 5,000 transactions per second. But yeah, I mean, you cannot support 500 or 50, all of them very high throughput applications. Then it's it has its own limitations. Blockchain cannot. Yeah.
Can I answer this in a theoretical way?
Please go ahead. Please go ahead.
We have something like Visa has in fact now 10,000 transactions per second, approximately they say. Yeah. So can we have Zilliqa for Visa, Zilliqa for Airbnb, Zilliqa for?
You could then a sidechain kind of solution. You could build that.
High transaction, the public blockchain cannot do.
You could build that, but it's you're just doing redundant. I mean, you should come with a very clever idea, and I just feel that if you want, what you can do is you could take Zilliqa. I'm trying to refine your idea, which is you could take Zilliqa and try to find a sidechain kind of solution which is attached to Zilliqa, where not every kind of transaction goes to Zilliqa mainnet, and then you can have a bunch of these sidechain solutions. Each sidechain solution will cater to one specific application. That could be done. But having 1 million Zilliqa blockchain, I just don't find it interesting. Yes, please.
I'm with my company in digital advertising, and we have multiple publishers, and we are in the same space that you were mentioning. We're more for the consent thing. Where can I get in contact? Maybe get my developers and test some things out and explain our
So currently we are, I mean, if you have an idea at the idea level, we'll be happy to share it. At the implementation level, our smart contract platform is not ready yet. So you cannot implement per se. We are still working on the smart contract language specification, and once we have it, we are actually going to build it. So, but we are happy to have, to talk and discuss.Ure, and then we can certainly take it from there.
So will the smart contract layer be in the first testnet release or second?
It should start from the second. Yeah. First testnet is essentially Bitcoin-like network. Yes.
So do you feel that your team has the appropriate size? I mean, you probably want to attract talent, but everybody wants that. And so how are you handling that? How are you?
Well, talent is always short. Anyone who is doing anything and who has a very cool idea, who thinks has a very cool idea, always needs more hands. So of course we are short of hands, and that's why we are doing meetups everywhere to actually spread the word out to ensure that people know about Zilliqa, and if they find it cool, they could come and work with us in any capacity they want, either remotely or on site or So yeah, I mean we don't have 1 million hands, but yeah, we would love to have that one day. Yes, please.
I have two questions.
Yeah.
The first one is how do you plan to implement the smart contract layer? Are you going to use kind of the Ethereum virtual machine type of idea? Are you going to kind of do something different? How does that
So the current idea is to go with the EVM kind of idea, where you take those bytecodes that they have, try to remove some of the bytecodes that we feel that it introduces security risks, remove that, and then map your Scilla language component to EVM bytecode. So this is something that we have in our plan.
that'll run on each node within the shard, yeah? Or
Yeah, you could run it on each node within a shard. Yeah.
the second question is
Yeah.
a little bit kind of more future oriented. I'm a scientist, I have a background in physics, and I was interested in what type of scientific decentralized applications you would envision perhaps running on the Zilliqa mainnet.
One scientific application could be running machine learning models, for instance. Which is very futuristic, I would say, but but considering the fact that most miners already have a GPU, why don't we find an application like machine learning which actually require which actually run very well when you have a GPU, and see how well it works. So this is one application that we do have in mind. Any other question? Oh, thank you so much for your question.